Hello and welcome to this lecture about overall timeline of a mining project. This lecture is part of the course Mine Design and Mining Economy, and my name is Pavel Manzoor. I'm a PhD student at Luleå University of Technology, Sweden. Well, this lecture is very general and covers different stages of a mining project. The term mining is used in a broad context, which means the extraction of naturally occurring mineral substances from the earth. Mining has played an important role in human civilization as it is considered as the second of humankind's earliest activities after agriculture. It has evolved a lot since then, especially during the last 2 centuries. There has been great progress in mining technology in many different areas. With all these developments, a modern mine goes through 5 distinct stages during its life. Let's have a look at the stages of a mining project. It starts with prospecting, goes through exploration, development, exploitation, and ends at reclamation. Prospecting and exploration, the first 2 stages, are forerunners to actual mining, as these are carried out before extracting the mineral from the earth. These stages are linked and often combined together. Geologists are mainly responsible for these stages. However, mining engineers play some role in exploration phase as well. The next 2 stages, development and exploitation, are closely related to each other, and these are the ones which are responsible directly towards mineral extraction. These are the stages where mining engineers play their main role. Reclamation is last but an important part of the mine life because of strict rules about closing a mine and also regarding preservation of the environment. Mine planning engineers are the ones who are responsible for planning this stage. However, geologists and sometimes civil engineers also work together to make the land reusable. The overall process of developing a mine with future uses of the land in mind is termed as sustainable development. Let's discuss these stages in more detail and one by one. Prospecting is the first stage in utilization of a mineral deposit. It is the search for ores or other valuable minerals. We are searching, we are looking for anything which is valuable in this stage. Prospecting techniques can be direct or indirect depending upon the location of the mineral deposit. For example, if it is at the surface of the earth or it can be below the surface of the earth. So, based on the location of the deposit, we have direct methods and indirect methods. The direct method of search is normally limited to surface deposits. It consists of visual observations, which can include either the exposure of a deposit or the loose fragments that have weathered away from the outcrop. Direct techniques involve aerial photography, geological maps, and structural assessment of the area. Indirect methods are mostly used for hidden deposits. The most valuable scientific tool used for this purpose is geophysics. It detects the subsurface anomalies based on physical measurements of Earth's gravitational, seismic, magnetic, electrical, electromagnetic, and radiometric variables. Indirect methods can also include geochemistry, quantitative analysis of soil, rock, and water samples, geobotany, and as well as analysis of plant growth patterns in that area. Once it is established that there is something valuable in an area, The next stage of mining project starts, which is exploration. This stage of prospecting usually takes 1 to 3 years and it costs approximately zero point 0.2 to 10 million or zero point 0.05 to $1 per ton of the deposit based on the area and quantity of the deposit. It can be more or it can be less, but this is just some guideline or general information about the prospecting. The next stage is exploration, which determines the size and value of the mineral deposit as accurately as possible. The techniques used in this stage are similar to prospecting but are more refined. The difference between prospecting and exploration is not very clear. This stage uses a variety of measurements to obtain a more positive picture of the extent and grade of the ore body. Samples are taken from the mineral deposit by different techniques, which include chipping outcrops, trenching, tunneling, drilling, and borehole logs. These samples may be subjected to evaluation techniques, which include chemical, metallurgical, X-ray, spectrographic, and radiometric evaluation. After evaluating these samples, we can describe the size and value of the mineral deposit. These techniques enable the calculation of tonnage and grade or richness of the mineral deposit. At the end, the profitability of the mineral deposit is concluded by analyzing different costs involved in different stages of the mining project. This overall process of the examination and valuation of the ore body is known as reserve estimation. This stage usually lasts up to 2 to 5 years and it costs $1 to $15 million based on the extent of the deposit. This picture here shows an example of the scale and cost of the techniques involved in prospecting and exploration stages. Here we can see we start from a very large area using geological maps, which are not very costly. And as we increase our geological studies and go towards drilling, which is very expensive technique for exploration, the area of the interest is decreasing. We are zooming into a small area which has high intensity. So with the time, we reduce our area of study, but we are increasing the cost as well at the same time. In the drilling process, usually diamond drilling is used to collect the drill core samples of the deposit. These stages are mostly carried out under the supervision of some governmental company or department. At the conclusion of this stage, the project is developed by the same company if they have the resources and expertise, or traded to another company who has the required resources or expertise. Or it can be abandoned as well if the mineral deposit is found unfeasible to mine out. If the deposit is found enough to be feasible to mine out, the next stage begins, which is the development. But before going in further into the mining stages, first I would like to clear an important concept, which is the difference between resources and reserves. A resource is the amount of geologic commodity that exists in both discovered and undiscovered deposits. However, reserves are the subgroup of the resources that have been discovered have a known size, and can be extracted at a profit. Resources convert to reserves based on increased mine planning and economic analysis of the mining project. We have different types of resources and reserves based on the available geological information and the level of confidence in their estimation. We start from inferred resource, for which tonnage grade and mineral content can be estimated with a low level of confidence. It is assumed based on the vicinity of the resource and may not be supported by samples or measurements. Next is indicated resource, which has some geological information available due to limited exploration and have higher level of confidence in its estimation than inferred resource. If the indicated resource is supported by the mining and economic data as well, it changes to probable reserve. The resource with highest available geological information is known as measured resource. Measured resource, which is mostly supported by diamond drilling. Its tonnage and grade are calculated with highest level of confidence. If the measured resource is supported by mining and economic data to be feasible to extract, or if the probable reserve is supported with more geological information, they will be termed as proved reserve. However, sometimes the mine planning and economic analysis may suggest the feasibility of a mineral deposit at a later time. For example, when the prices change in the market or there is need to enhance the geological information about the resource. The measured resource then can be termed as probable reserve as well. This picture here shows the difference between different types of resources based on geological data collected from prospecting and exploration. For example, we have inferred resource, which is only assumed based on the continuity from the resource that we have here in the form of measured and indicated. So it is only based on assumption. There is no support coming from the exploration and prospecting. The next one is indicated resource, which has little information available in the form of one drill hole here, while the measured resource has the most information available based on many drill holes. So the resources are categorized based on the geology, which are basically the exploration results. However, the reserves are based on the exploration results as well as economic data that we have in the mine planning field and economic analysis. So we have here a measured resource, all of it, and then we have two types of reserves here, proved and probable. Proved is the one which we can mine at a profit. We know that if we mine it out, it will give us some profit. But about the probable, we are not sure. We we can assume that we can mine it out economically, but maybe at some later stage and with some different mining method. Because here you can see we are going to excavate this one with some surface mining method, and then later on this probable reserve will be mined out with some underground mining method. Now, when we have established that the deposit is proved reserve, we will move to the next stage of the mining project, which is development. In this stage, the work of opening a mineral deposit for extraction is performed. This stage starts the actual mining of the deposit, which is called as ore onwards. There are certain preliminary steps which are generally required before the development starts, which involve acquiring water and mineral rights, buying surface lands, arranging for financing, preparing permit applications, and environmental impact statements. After these steps, access to ore must be gained either by stripping the overburden, which is the soil or the rock covering the deposit, to expose the near surface ore for mining, or by excavating openings from the surface to access more deeply buried deposits to prepare for underground mining. Development also includes provision of auxiliary facilities, which must be provided before actual mining starts. These facilities include access roads, power sources, mineral transportation systems, mineral processing facilities, waste disposal areas, and offices and other sport facilities. Development for surface mining is relatively simple as compared to underground mining. Stripping ratio is an important concept which is mostly used in surface mining, which is the ratio of waste removed to ore recovered. It tells us how much waste should be removed for a certain amount of ore excavation. Because of complexity and expensive nature of development for underground mining, careful planning and layout of the access opening is required for the efficient mining, safety, and permanence. Development can continue during the exploitation stage as well, but initially it takes 2 to 5 years normally before the start of mineral extraction, and it costs of approximately 10 to 500 million dollars based on the nature of the mining project. Here, this picture shows different access openings in an underground mine. We start from tunnel, which is an horizontal opening in the rock mass with its both ends open to the surface, while in this adit, it is also a horizontal opening, but it has one end which is open to the surface, but the other end is in the rock mass. Shaft is similar to the adit, but it is vertical instead of horizontal. It has one end open to the surface and the other end in the rock mass. And decline is something in between adit and shaft. It is an inclined opening at some angle with the horizontal. The mouth of all these openings, tunnel, portal, shaft, or decline, which is open to the surface, is known as portal. Level is a horizontal opening, but it is in the rock mass. It does not open to the surface, and it connects the ore body with the shaft or decline, whichever we use to go into the earth. Then we have raise, which is a vertical opening going upwards from the adit or level, and winze, which is also a vertical opening, but it goes downwards from the adit or level to reach the ore body. Then we have crosscut, which connects different levels at the same elevation. And then we have at the last sump, which is a small pond at the end of shaft or decline to collect the water coming into the mine. Drift is left behind. It is also a horizontal opening, but it runs into the ore body. It- The next stage is exploitation, which is the fourth stage of the mining, and it is associated with the actual recovery of the minerals from the selection of the mining method is an important aspect in exploitation. It can make a feasible project to unfeasible if we select the wrong mining method. It is an important aspect and it is determined mainly by the characteristics of the mineral deposit and the limits imposed by safety, technology, environmental concerns, and economics, as well as the geological conditions such as depth, shape, and strength of the ore and the surrounding rock. Traditional exploitation methods fall into two broad categories based on the location, which is surface or underground. This stage usually lasts for 10 to 30 years based on the nature of the project, but it can be even extended up to centuries if the deposit is too big or if the extraction rate is too low, it can go for decades or centuries even. And it costs $5 to $75 million or per year or $2 to $150 per ton of the material excavated. Before going to the next stage, let's have a very brief look into the surface and underground mining methods which are used in exploitation stage. Surface mining is the predominant exploitation procedure worldwide. It includes mechanical excavation and aqueous extraction methods. Mechanical excavation, that means extracting the mineral or the rock by using some machine, includes different methods. For example, open pit mining, open cast mining, contour strip mining, auger mining, and quarrying. While the aqueous extraction, which, which means extracting the mineral from water or some liquid, involving some sort of liquid to extract the mineral. It includes different techniques like panning, sluicing, dredging, leaking, and leaching. There can be other special or modified surface excavation methods as well, but these are the conventional or traditional ones. The first one, which is open pit mining, is a surface mining method where rocks and minerals are removed from an open pit near the Earth's surface. A thick deposit is generally mined in benches or steps, although thin deposits may require only a single bench apiece. It often requires large capital investment, but generally results in high productivity, low operating costs, and good safety conditions. The image shows different parts of an open pit: bench space, bench height. These are some details, but we are not going into my details here. The next one is open cast mining, which is also known as strip mining. It is a method of extracting substances such as coal from the ground that involves removing the top layer of the soil instead of digging deep into the earth. Unlike the open pit mining, which proceeds downwards, open cast mining usually proceeds sideways. The next mechanical excavation method is contour strip mining. which is applied in hilly areas where the mineral is exposed at the surface along the hillside. So the excavation looks like these benches look like the contour of the mountain. So instead of digging into the earth, we cut the side of the hill and extract the mineral. Next one is auger mining, which is a method used for removing pores by boring into the pore seam at the base of strata exposed by excavation. For example, if we were excavating using strip mining and we reach to an extent where we cannot further proceed, there is something on the surface that we cannot disturb, and then we use auger drill machines at the bottom of the excavation and we drilled into the pore seam to extract the pore instead of going further into the deposit. These are here uh, the images of an auger drill machine. The last excavation method in mechanical excavation is quarrying. It is used for dimension stone or aggregate mining, which can include sand, gravel, or crushed stone. And the products of dimension stone quarries are prismatic blocks of rock such as marble, granite, limestone, sandstone, and slate. So instead of blasting the material, we normally cut the material into the blocks because the shape and the integrity of the product is the major concern here instead of the production. Normally the blocks are cut using some cutting tools. Then we have aqueous extraction methods. The first one is very simple one, which is known as panning. Panning in mining is used for separating particles of greater specific gravity, especially gold from soil or gravels, by washing in a pan with water. It's a very primitive sort of aqueous extraction method where we use some pan. We take the sediment of the river or some flowing material, water into the pan, and then we just wash the low specific gravity material out of it, and we keep the higher specific gravity material, which is mostly gold if it is found in that area. The next one is sluicing. In sluicing methods, we use a slightly sloping wooden rack, which is known as box sluice, or we can use something which is a ditch cut in hard gravel or rock, which is known as ground sluice, and we use these tools as a channel along which gold-bearing gravel is carried by a stream of water. So the water flows through this device, which is sluice, and then we have riffles which are placed transversely along the bottom of the sluice, which cause the water to swirl into small basins, retarding the current so that gold may settle and be trapped at the bottom of these sluices. Next one is dredging, which is underwater excavation of a placer deposit by floating equipment like this ship, and it has some cutting tool which goes into the water to excavate the material from the bottom of this water body. Next one is hydraulic mining, which is a which uses high pressure jets of water to dislodge rock material or move sediments, and from that water uh, we extract the required mineral. The last one in aqueous extraction is leaching, which is chemical process in mining for extracting valuable minerals from ore. There are two main types of leaching. Uh, First one is heap leaching, and the other one is in situ leaching. In heap leaching, we have a heap of the ore or rock, and then we have some acid rain on this heap that dissolves the required mineral from the heap and extracts it. While in this in situ leaching, we have these wells. From one of the wells, we inject some chemical into the earth, and from the other well, we take that chemical out, which has the dissolved mineral in it, and is a very common in uranium deposits. Heap leaching is also known as acid leaching, while in situ leaching is also known as in situ recovery or solution mining. Then we have underground mining methods. Underground mining is the process of extracting minerals and ores that are located too far underground to be mined efficiently using some surface mining methods. The primary objective of underground mining is to extract ore safely and economically while minimizing handling of the waste rock. There are several different methods of underground mining, which include unsported, sported, and caving methods. The unsported methods of mining are used to extract mineral deposits that are roughly tabular, and it can be flat or stiffly dipping, and are generally associated with strong ore and surrounding rock. These methods include room and pillar, stop and pillar, shrinkage stopping, and sublevel stopping methods. The sported methods of mining are often used in mines with weak rock structures. We need some kind of force in the mine to make the working environment safe. Otherwise, there can be some failure of the rock. These methods include cut and fill, square set stopping, stirrup stopping, and vertical crater breaching. Caving methods of mining are varied and versatile and involve caving the ore or the overlying rock, that is, the subsidence of the surface, which occurs afterwards when we have extracted the ore. These methods include longwall mining, sublevel caving, and block caving. There can be other special or modified underground mining methods as well, but these ones are the conventional or traditional. The first one is room and pillar mining. It is the most common unsported method, which is used primarily for flat-lying seams or bedded deposits like coal, fauna, limestone, and salt. Support of the roof is provided by natural pillars of the mineral that are left standing in a systematic pattern, like we can see in this picture. And size of the pillar and the size of the room, which is this opening here, it can be different for different materials based on the strength of the material. Next one is stop and pillar, which is similar to room and pillar, but it is used in non-coal mines where thicker and more irregular ore bodies occur. These pillars are spaced randomly instead of systematic placement as we see in room and pillar, and are located in low-grade ore so that the high-grade ore can be extracted. This image here looks more like room and pillar because it has systematic pillars, but if they are placed randomly in low-grade instead of high-grade, it will be stop and pillar. And stop is basically a production opening in a metal mine from where mineral or ore is extracted. The next one is shrinkage stopping, which is the method where mining progresses upwards. We start from the bottom of the ore and we keep on extracting the ore going upward, with horizontal slices of the ore being blasted along the length of the stope. So we cut a slice at the bottom, we blast it, and we take it out. Then the next slice, then the next slice, then the next slice. Broken ore, some of the broken ore can be left in the mine, which provides a working platform for the miner, as we see here in this picture, to reach the roof of the ore. But once all the ore is extracted, this leftover broken ore is also extracted at the end using these openings which are known as chutes. Sublevel stopping is another unsupported underground mining method, and it differs from shrinkage stopping by providing sublevel from which vertical slices are blasted. In shrinkage stopping, we don't have sublevels. We just stand on the broken rope and we keep blasting horizontal slices. But here in sublevel stopping, we have these sublevels to reach the ore, and then we blast the vertical slices instead of horizontal slices. And we start mining from one end to the other end of the ore. So the stope is mined horizontally from one end to the other end. Shrinkage stopping is more suitable than sublevel stopping if we have stronger ore and weaker wall rock. Cut and fill is the first one in the supported mining methods, underground mining methods, which is used primarily in steeply dipping metal deposits. It is the most common one in supported underground mining methods. The ore is taken out as horizontal slices, and the void or the opening is then filled with a variety of fill types to support the surrounding rock. This fill can be rock waste, tailings, cemented tailings, or any other suitable material that can provide the necessary support. So here in this picture we can see we cut this horizontal slice and then we fill it up with some backfill material, and then the next slice, and then the next slice, and then the next slice. But this next slice can be above the backfill or it can be below the backfill as well. So based on the location of the next slice, either it is above or below, we have two types of cut and fill, which are overhand and underhand. In the overhand, we cut the upper slice, and in the underhand, we cut the lower slice, which is below the backfill. So we have roof of the backfill and we are working into the ore. But if we are working with overhand cut and fill mining method, then the backfill is not roof, it is the flow. Cut and fill is one of the most popular methods used for vein deposits and has recently grown in use. Then we have stair set stopping, which involves backfilling mine voids. However, it relies mainly on timber sets to support the walls during mining. So these timber supports are placed in a stair shape. That's why it is called a stair set. And this method is not common in those areas where the labor cost is high and also where uh, cutting of trees and the environmental aspects are important. But the areas where this labor cost is not that much high, it's still very common and popular method. Next one is Stoking. It is also similar to scare set because it uses timber for the sport, but it can use rock walls as well in some tabular or pitching over bodies. Over bodies that and over bodies that have dips between 10 degrees and 45 degrees are mostly mined out using Stoking instead of scare set stocking. And it often utilizes artificial pillars of base to support the roof as well. But that square shape is not that important here. The timber can be uh, piled up in any shape based on the available space. Next one is vertical crater retreat. Crater retreat can be either a supported or unsupported method based on the crater blasting technique in which powerful explosive charges are placed in long diameter holes and fired. We have these long and large diameter holes, and then we place the explosive in it. But the holes are not blasted all of it once. We uh, charge the hole partially, we blast it, and then we charge the hole partially, and then blast it, and then charge, and then blast. So the hole is not blasted at once. Part of this blasted ore remains in the stope over the production cycle, serving as temporary support for the stope walls. Then we have the caving method, and the first one is long wall caving, which is particularly well adapted to horizontal seams, usually coal and some, which is at some depth. In this method, a face of considerable length is maintained, and as the mining progresses, the overlying strata are caved. So we have these two side openings where we have some uh, belt conveyors, or it can be some other uh, haulage method as well to take the material out of the mine. And then we have this long face here, long wall, and we have these hydraulic supports mostly to provide a safe working environment. And then we have this long wall mining machine that cuts the coal. So the coal is then transported through these back conveyors. And behind these hydraulic supports, this rock material is caved in and the surface subsides downwards. Next one is sublevel caving, which is also a high production method, but it can be applied to metallic mines as well. But the longwall mining is mostly used in coal deposits. It is employed for dipping tabular or massive deposit. As mining progresses downward, each new level is caved into the mine openings, with the new materials being removed while the rock remains behind. So we have levels and sublevels here to access the ore from the shaft or the ramp that is used to reach the deposit. And then We are going downwards and making new levels, and the previous levels are blasted, ore is taken out, while the waste is just left behind and the surface is caved in. The next caving method is block caving, which is a large scale or bulk mining method that is highly productive, low in cost, and used primarily on massive deposits. It is most applicable to weak or moderately strong ore bodies that readily break up when caved. Block caving will involve undercutting the ore body, allowing the ore to collapse and fragment into underlying draw points. So here is a very simple picture where we blast to provide an undercut. So we break this material using blasting, and then this material is taken out, and the upper material then breaks itself because of its weak strength. It is weak, so it starts caving also, and it comes down, and we extract it using these draw points, while this waste material is left behind. Block caving will involve low cost as compared to the sub-level caving. In addition to these conventional methods, innovative methods of mining are also evolving, like rapid excavation or underground gasification or liquefaction, or we have deep sea mining. But these are the most conventional or traditional ones. With the increase in automation, there are modifications and changes coming up in the mining methods as well. These, after discussing these common mining methods, next we move to the last stage of the mining project, which is reclamation, which involves closing a mine and recontouring, revegetating, and restoring the water and land value. It is the final stage of the mining project. The reclamation process should be considered along the development and exploitation before the first excavations are initiated. We do not need to wait until the exploitation is done and then we plan for the reclamation. That will not be the best option. We need to plan the reclamation along the development and exploitation. Mining engineers, the mine planners, should plan the mine so that the overall cost of mining plus reclamation is minimized, not just the cost of mining itself. So if the planning engineers are mine planning engineers are planning the reclamation along development and exploitation, this overall cost of mining plus reclamation will be minimized. Otherwise, they will just minimize the cost of mining, and then at the end, reclamation cost will be much higher. Sustainability is an important concept in mining industry nowadays. That means the meeting of economic and environmental needs of the present generation while enhancing the ability of future generations as well to meet their own needs. Reclamation stage needs special planning as it should address three main concerns. The first category is about the safety concerns, especially if the area is open to the general public afterwards. It includes the removal of office buildings, processing facilities, transportation equipment, utilities, and other surface structures. It, the mining company is then required to seal all mine shafts, adits, and other openings that may present physical hazards. They also need to modify any existing high wall or other geologic structures to prevent injuries or death due to geologic failures. Second category is about restoration concerns. It includes restoration of the land surface, water quality, and waste disposal areas so that long-term water pollution, soil erosion, dust generation, or vegetation problems do not occur. Planning of the waste dumps, tailing ponds, and other disturbed areas will help to prevent pollution problems. Final major concern is the subsequent use of the land after mining is completed. Old mine sites have been converted to wildlife refuges, shopping malls, golf courses, airports, lakes, underground storage facilities, real estate development, and solid waste disposal areas. And there can be other uses as well that can benefit society. It normally takes 1 to 10 years and cost of approximately 1 to 20 million per year dollars based on the size of the mine. The successful completion of the reclamation of a mine will enhance public opinion of the mining industry and keep the mining company in the good graces of the regulatory agency. The fifth stage of the mine is thus of paramount importance and should be planned at the earliest possible time in the life of the mine. Thank you for listening to this lecture about the stages of a mine life. Hope it helped you to clarify the concepts discussed in the lecture. Have a nice time. Thank you.